All right. Wanted to go over a power series question, specifically this one. I want to evaluate this integral as a series. First thing you should think about though is why would I do this? Looking at this, look at the integrand here. I mean, can I just take the integral without thinking of it as a power series? Well, if I were going to integrate this, I would have to probably use integration by parts because I have a product. So u would have to be the algebraic expression, right? U would have to be x squared, which means dv would be sine of x squared, but there's no integral for sine of x squared. That's one of those functions which has no antiderivative, so we're totally screwed. Which is the motivation as to why I want to integrate this as a series. So, first thing you need is what is the power series of sine of x? So, sine of x is equal to the sum from n equals 0 to infinity of -1 to the n, x to the 2n plus 1 divided by 2n plus 1 factorial. So yeah, that looks right. That looks right. Which means, what is the power series of sine of x squared? Remember how this works? When I used to teach Calc 2, people had a lot of problems with this kind of thing. You want to just behave like a robot. This is sine of x. Okay, there's my x. Sine of x squared. I'm replacing x with x squared. Replace x with x squared. Nothing going on really. Just behave like a robot. N equals 0 to infinity, -1 to the n, x squared, 2n plus 1. Again, I mean, replace x with x squared. That's all I did. Nothing crazy. Divided by 2n plus 1. Now I need to multiply by x squared. All right, let's do that. All right, which means that x squared times sine x squared. Okay, let's multiply. So this is, I know how to multiply. X squared times the sum from n equals 0 to infinity, -1 to the n, x squared to the 2n plus 1 divided by 2n plus 1 factorial. Think about this for a second. This limit, this sum, only depends on n. I can bring anything in and out as long as it doesn't depend on n. So this doesn't depend on n. Bring it in. X squared, you think of this as x squared, you can think of it as x squared to the power of 1. This is x squared to the power of 2n plus 1. I'm multiplying two things. They both have base x squared. Add the exponents. So that means this is equal to the sum from n equals 0 to infinity, okay, -1 to the n, x squared to the what? This is, again, you need to really think about this. X squared to the 1, x squared to the 2n plus 1. Just add the exponents. That's how you multiply things at the same base. So x squared to the 2n plus 2 divided by 2n plus 1. All right, we're looking good. We're looking good because now we've expressed the integrand as a power series. So now what? Now what? Now, let's make the substitution. I'm going to plug this power series into the integrand. This is my integrand now. So what is my integral equal to? So the integral, so hence, the integral of x squared sine x squared dx is equal to the integral of this business, of the sum from n equals 0 to infinity of -1 to the n, x squared to the 2n plus 2 divided by 2n plus 1 factorial. All right. Dx. So one thing I may want to do is I may want to combine the powers right here. Dogs like to bark when I make a video, so that's pretty cool. Thanks, guys. So, so we're going to multiply these exponents. Whatever. Let's just do that real quick, right? This right here is going to be x to the 4n plus 4. So no big deal. All right. All right. Here is actually quite a delicate matter. What we want to do here, and what you can do if you're in Calc 2, is you can just do this at will without any justification. We want to change the integral with the infinite series. If this is a finite series, no big deal. It's just perfectly legal because the integral is a linear operation. But the infinite series, you have to be careful. This is only true if the infinite series converges. So, thing is, the infinite series for sine of x squared, the power series, converges actually for all real numbers. And so, when I do this sort of transformation with this sum, it's still going to converge. So because it converges, I can exchange the sum, the infinite sum, with the integral. So this is equal to the sum from n equals 0 to infinity. Okay. Now I want you to think about this for a second. If I'm going to exchange these, remember if I exchange these two, the integral, okay, anything in the integrand which does not depend on x can also come out of the integral. Think about this for a second. What kind of things are in here that don't depend on x? Pretty much everything. So this is negative 1 to the n divided by 2n plus 1 factorial, now times the integral. I'm taking everything out of the integral that doesn't depend on x. All this doesn't depend on x. How nice. So now this is x to the 4n plus 4 dx. I mean, it's really just about understanding what you're doing. I mean, this is easy peasy, right? This is just power rule in reverse. Increase and divide the exponent. So we're pretty much there. All right? So this is equal to the sum from n equals 0 to infinity, negative 1 to the n divided by 2n plus 1 factorial. Antiderivative, add 1 to the exponent, divide. This is x to the 4n plus 5 divided by 4n plus 5 plus c. That's it. So this is my answer. I mean, this is a power series which represents the solution of this integral. Let me know what you think. Like the video. Thanks for watching.